Welcome everybody. This is day 2 of our lighting week, if I may. It's the smart building design workshop, and we have Chase Anderson and Bo Chen with us from Acuity Lighting. Chase yesterday took us through some portion of the lighting controls aspects, and he's going to continue with it. And Bo will get into some of the lighting control specifics and integrating lighting with the smart building at large. So with that said, I just want to welcome everybody and pass it over to Chase to get things going.
Awesome. Well, thank you so much, Anoop. And once again, thank you to the Distech marketing team for putting this together and giving Bo and I the opportunity. Like we said yesterday, my name is Chase Anderson, Specification Sales Manager at Acuity, and I have with me Mr. Bo Chen. Bo, you want to introduce yourself real quick again?
Hi, good to see everyone today. I'm glad to have everyone on, and please feel free during the session to type in your questions in the chat box, and we look forward to answering them. And cheers.
Awesome.
Absolutely. And just a quick reminder as well, these are PDH accredited presentations. Between yesterday and today, that's one PDH. Last week was one PDH, and next week will be another PDH. So for those of you who are looking for that, rest assured that you will be getting your certificates emailed to you, and PI New York will be notified of your attendance. So go ahead, Chase.
Perfect, good deal. Thank you, guys. So I'm going to kick us off here and just kind of pick up where we left off yesterday, and then I'm going to hand it over to Bo to bring it on home for us as far as the unified lighting controls portion of this workshop goes. So yesterday we laid out how a lighting controls platform forms part of a building's operational technology stack. So today we're going to continue on that same theme as we work towards the integration with a building automation system to achieve that goal of providing a facility manager with that one pane of glass that's going to enable the information technology side of our operational and information technology marriage. So with that, we'll go ahead and get started here. So yesterday, this is all the action items we went through. We kind of discussed why a controls platform is necessary, how a controls platform communicates either wired or wirelessly, and then all the various field devices that are going to comprise our platform. So today we'll expand upon that, and we'll talk how relays, sensors, switches, and luminaires are going to connect to an upstream system controller. And then I'm going to hand it over to Bo, and he's going to take it home for us and kind of talk about how we're going to tie a lighting controls platform into the building automation system, and then how that will lend itself to IoT applications. So with that, we will keep moving here with the platform backbone. So while the relay, sensor, switches, and luminaires that form a zone can function on their own completely independently, we really are able to take full advantage of a lighting platform's full potential when we network these zones using an upstream backbone. So there's 3 devices that comprise this platform backbone that we're going to discuss today. The first of which is the bridge, followed by the system controller, and then finally the lighting management software. So we have to start with the bridge. So that's the first of which. So to form our networked wired system, our daisy chain downstream devices, like we said, sensors, switches, relays, and luminaires are going to connect to a bridge via the Cat5 bus. And like we mentioned the other day, it makes no difference the order in which those devices are plugged into our Cat5 bus. Just a quick note. So multiple zones are able to connect to a bridge via the mini RJ45 ports in each bridge. So as you see up on the screen here, as an example, we have 8 RJ45 ports in this bridge. So that would allow us to have 6 zones of control, and then an input reading from the previous bridge and an output going to the next bridge if we do want to build upon our system and connect multiple bridges with each their 6 zones to one another. So our bridges are going to act as hubs. They're going to collect information from all the downstream devices and then push it to the upstream controller. And bridges prevent us from needing home run cables between individual devices going to the system controller. So it really cuts down on the amount of Ethernet cable that's required. And then also bridges are going to help redistribute power between various zones. So if there's a surplus of power in one zone and a deficit in another, it'll rebalance to make sure that everything, all our different zones are equally powered. So this is for a wired system, but in a wireless system, bridges go away. We don't need them because our wireless sensors, switches, relays, and luminaires are going to connect directly to the next backbone device that we'll talk about via radio frequency. So our next device is going to be the system controller. And so this is where our Cat5 lighting control bus terminates. So it's going to be the most upstream piece of hardware we have in the lighting controls network. In the case of wireless, as you see up on the screen here, we're going to use an adapter that's going to communicate via radio frequency to all of our field devices. But the system controller is going to connect the lighting platform to the local IP network via a Cat5 connection. And this controller is going to collect all the downstream data from devices, and because of its IP connection, it's going to make all this data remotely available through the software that we'll talk about next. So with our system controller, we're able to set time-based scheduling events, and then we can also run an automated demand response so that we're able to cooperate with local utilities. One thing to keep in mind is that these system controllers do have a downstream device limitation. So the piece of hardware we see up on our screen here, for example, has 750 devices. And while that seems like a lot of devices, if we do have multiple floors of a building, that will quickly add up. But we are able to connect multiple system controllers to one another if we do exceed that 750 device limit. So from the controller, we're able to upgrade our firmware and then change settings to all downstream devices from our software. And this system controller is what allows for the integration with BAS via BACnet IP, which we'll detail here in a second. So next, we're going to move on finally to our software. So like we mentioned, since our system controller is connected to the local IP network, we are able to run a lighting management software on a computer connected to the network. So different manufacturers are going to offer different software options, but most often these programs are going to be free, and they will simply allow authorized users kind of an intuitive dashboard that allows us to remotely monitor and configure all our lighting platform control devices. So this is from this software is where we would push our firmware updates and then change our settings as well. So this is the interface that we're able to make all those changes within. So from our system controller, we can also run edge applications like energy monitoring and space utilization. And so when we started yesterday, we kind of talked about all the disparate systems that a facility manager needs to manage, be it HVAC, security, fire. So the lighting management software would be one of those individual systems that ideally will be able to integrate with other control systems to allow for the goal of a facility manager having that one pane of glass to manage instead of a separate lighting, fire, security, etc. So finally, we will look at the big picture here. So we see here up on the screen, we have our zones of wired luminaires, sensors, relays, and switches, and those are going to connect to a bridge, which connects to our system controller via Cat5. On the exact same site, we also have the option to use wireless luminaires, sensors, relays, and switches, and that would bypass, and that example, we would not need a bridge because all of our wireless devices are going to connect directly to the system controller via radio frequency. And then this system controller then has the capability of connecting, like we said, to the building automation system via BACnet IP, which I'll turn it over to Bo to take it from there. So Bo, it's all yours.
Thank you, Chase. So next I'm going to talk about building management integration with lighting. With that, so hopefully everyone can still see my screen. I'm CV.
You might want to put it on full screen, Bo.
Yeah. So I don't know why right. Is everyone able to see the screen or no?
No, it's a blue screen at the moment.
Okay. Hold on a second. Sorry about that.
That's better.
Yeah, you're able to see the full screen now?
Yeah, that's better.
Okay. So this kind of stuff never happens when it's supposed to or not supposed to. So thank you for your patience with that technical difficulty there. So good question, right? Why integrate BMS or BAS with lighting? When you look at what those two mean in terms of what lighting and what HVAC represent as far as total energy consumption, it's upwards of 70% plus. So it's a good idea to somehow integrate those two and make the best use of them. And even though they're the biggest expense, it's also the biggest source of complaint. I don't know if you work in an office with diverse demographics. I definitely do. I'm in an office that has people from different countries, people at different ages, and you know, and different sex, male and female, obviously. And so I'll just give you an example. We have people who like brighter light levels because they're older. There's another person that sits right next to her that's maybe 10 years younger or 20 years younger, and that person likes it very dark. That person is male, and he's like Batman. He likes that area very, very dark. And so there's this a difference in terms of preference and what optimizes performance for different individuals. That's on the lighting side. On the HVAC side, I'm sure people have experienced this, and that is, you know, you have cold spots and hot spots, and you also have people who want an environment to be cooler or warmer. You know, I don't know if any of you have worked in an office where certain people have, you know, small personal heaters that they use throughout the year, not just the winter months, but also the summer months. So I work in an office, and I'll just give you an example of these four individuals, myself being one of them. We have a middle-aged woman that's about, I don't know, 5'4", weighs about 100 pounds or something like that. We have an older gentleman that's about 65, and then we have someone that's about 30. And they all come from different places. The woman comes from Buffalo, and so she's used to colder weather. We have a person that's from New York, and then we have a person from Southeast Asia. And so the older gentleman and the younger gentleman both have heaters on in the winter as well as the summer. Meanwhile, the middle-aged woman, she tends to be able to weather the colder climates and is very comfortable in cooler temperatures. And me, being probably right in the middle there, I'm about 5'11". I'm in middle age, in my 40s. I like long walks on the beach, and I like the sunset, taking applications for companionship. Just kidding on that one. So yeah, me, I'm kind of in the middle, and I could deal with the different temperature ranges, and I'm not as picky as some of my colleagues where I would need a personal heater. So I mean, those are examples, and it's not so extreme. I'm sure some of you have experienced some of this stuff. So being that it's biggest expense, it's important to somehow coordinate those two and make those work to increase productivity. I'm sure some of you have gone to the office where it's like so hot or so cold that it kind of distracts you from doing the work that's at hand. So with those two systems, the BMS side, there's a lot of functionality that needs to happen, and the same thing on the lighting side. In particular, I'm on the lighting side, and there's a commissioning process on the lighting side where you set lighting levels, scenes, and zones, and you do the same thing on the BMS side, where you're watching for energy, you're doing the zoning and stuff like that, and you're doing profiles for temperatures for certain rooms. And so, do those necessarily meet? And sometimes they do not. But each one of those systems is pretty robust and has to do a lot, and a lot is being asked of them. And each one is tasked with slightly different things, and if we go and kind of look at what some of those expectations are, what some of the pain points are, it's some of that communication that happens in terms of some of the expectations. So I'll give you an example. When you go into a room and you turn on the light switch, do you expect the lights to come on instantaneously? Yeah, but do you have the same expectation for HVAC? No, you don't expect the room to cool instantly. It'd be nice, or warm instantly. That'd be nice, but it takes time, and that expectation is certainly there. And so, in terms of how that works and what is being communicated from the customer standpoint, and what is being communicated from the integration standpoint of what is possible, what isn't possible, and what are some of the trade-offs that are given up, and is there agreement there? There are also a bunch of different languages from the BMS side, and they're the same thing on the lighting side, where there's whereas where LawnWorks and BACnet may be more widely used, on the lighting side there's a lot of proprietary software and communication that happens, and so integrating that is also a challenge because of the different languages. Scheduling, so as far as scheduling is concerned, so there might be conflicts that happen there that needs to be kind of talked through in terms of priorities. So maybe you want to turn on the HVAC at a certain time, and maybe you want the lighting to turn on the HVAC when the room is occupied. So there are different expectations there as far as, hey, do I schedule the lighting to take priority, or does the lighting trigger the HVAC, or is it the other way around? And so some of those need to be worked out, and if there isn't that coordination and agreement on what takes priority, and kind of think about how the occupants are going to be using in that space, how the occupants are going to be using the space, then it really does become a pain point, because the last thing you want to do is for if you are setting up a meeting and you know that you're setting up that meeting, you want those rooms to be cool at a certain time, but the lighting, if via some kind of vehicle, is supposed to turn on the HVAC at a certain time or turn off the HVAC at a certain time, it beats the purpose of some of the scheduling, which is something that you can do, right? So depending on how BAC, the lighting is controlling the HVAC or vice versa, there is a source of conflict there. And then naming, how the different points are being named on the lighting side and the HVAC side might not be the same, and because you don't call it the same things, then that is also a source of conflict and causes a lot of headaches during the programming and commissioning stages. So, what can really help resolve some of this is, kind of bringing those two networks together, right? Chase spent a lot of time talking about the the lighting side of things in terms of the lighting network and how that works, and the controller, the bridge, and the different components, wired and wireless. That's on the right-hand side of your screen. And then you have your left-hand side of the screen where that's the BMS. And seldom in the past do they kind of talk. Right now, you know, there are manufacturers that offer both the HVAC controller and the lighting controller that allows you to talk back. That allows you to talk backnet, and that is the bridge that you need to create that single pane of glass that Chase was talking about earlier. So, because those two controllers are developed together, you know that those the lighting side and the HVAC side will talk to each other, and it will function the way that you had intended it to function, and reduce some of those conflicts and increase comfort levels. I mean, there are times when, I'm sure you've seen this, where lighting zones and HVAC zones might not be the same. So just like occupants are supposed to be in a room where you want a certain temperature, that doesn't necessarily happen, and it makes occupants outside the room uncomfortable because it's too warm or too hot. Same thing with lighting on the lighting side. But because, you know, if you're able to bring those two together, it makes it a lot easier to integrate and for that to be able to talk to each other. And so in the center bottom is your single pane of glass that allows that to happen when you're able to integrate those two different networks when they both talk backnet and they're communicating the same language. And this, yes.
Well, just cutting in there. When you and I first worked on our combined unified BS and lighting project, you know, one of the challenges was when we worked with the engineer, Division 23 side of things and Division 26 side of things were designed independently, and ultimately we had a challenge to integrate them on the field. And then subsequently we worked it out. What you know, share some of your thoughts on you know, actually pulling some of those specs together and making sure that things go well from the design stage.
Oh yeah, that's a good point, Anoop. So I primarily work on the lighting side while or the electrical side, while Anoop typically works on the mechanical side. And so I have to say, in my last almost 3 years in New York City and working with electrical engineers, barely, you know, except for a few, the majority is that each one works in their own silo of, you know, you do your lighting part or your electrical part, and I do my mechanical part. And so initially, and our first project was not necessarily a total success, and we learned a lot from it because it wasn't a total success. And that is, you know, we were doing a lot of the lighting side independently of the mechanical side. It wasn't until we actually sat down and understood what the intent is, and how the occupants intend to use the space, and how they want those two systems to be controlled and integrated, so that it's a lot more seamless. So you know, we had to sit down and kind of understand what those zones were and how the lighting would control part of the HVAC and how it would trigger the HVAC to kind of go on. And part of it is to control the temperature as well. So you know, lighting people are not HVAC people, and HVAC people tend not to be, I speak in generalities, tend not to be lighting people. And that just human to human communication itself, it doesn't necessarily translate. And so when we humans are trying to program some of these things, it also doesn't translate because we don't know, you know, what some of the needs are on both sides. It was not until when we were actually sitting and talking to the mechanical group with the lighting group together that we were able to successfully execute this project to the way that was intended, right? That we talked about communication earlier, both from the owner side as well as from the manufacturing side of, hey, what is it that you want, and what is the system capable of doing, right? So there needs to be that understanding. And so it wasn't until that we were able to bring those two groups together, the mechanical group and electrical group, in order to have it successful integration between the two. So it certainly does take a team. With that, so what does it look like, and kind of to sum it up and bringing those two platforms together, you have, if you look from bottom to top, right, you have the hardware pieces. Chase spent a lot of time talking about the daisy chain and the parts and pieces on the lighting side. And then, of course, the HVAC side, you have the sensors. And then you have the controllers on the HVAC and the lighting side. And really what brings it together is the BACnet part of the, the BACnet, the communication protocol. So again, when you have manufacturers that provide both, you have a much better chance of integrating those two, having those two translate and work the way that it's intended, work the way that occupants and owners expect it to operate. With this, you know that it's a lot more reliable and predictable in terms of functionality. You know that when there are upgrades to each one of those softwares, that they would continue to work. Sometimes there's one software upgrades to one and not necessarily software upgrades to the other. That causes issues, and it takes a lot of time to diagnose what those issues are. But when you have the same manufacturer manufacturing those two, it makes it a little bit easier, less of an issue in terms of some of those upgrades that is supposed to give you increased functionality, but if they're not compatible, just gives you extra headaches, right? With that, those two controllers being able to talk together and being compatible from the same manufacturer, it's also easier to install. You know what to expect. Easier to scale from in terms of the size of the projects. If you want to have single floors, multiple floors, whole buildings to multiple buildings, and still maintain that single pane of glass. And then also service, right? Being able to go to a single manufacturer to be able to get all this sorted out without having to have people kind of saying it's not really the lighting side or the HVAC side. I'm sure we've all experienced a little bit of that to a certain extent. So that once you have that, those two communicating, then you have that single pane of glass that can translate to something more, right? And what is that more? So we spent a lot of time talking about, yesterday talking about the hardware that goes into place, and we talked about how power packs control certain zones, and that's the simplest way. And then we talked about bringing the control into the fixtures, and then we talked about having sensors and so forth going into the fixture, and then creating a network like you saw earlier today. And then finally, the last step is really being able to harvest all that software. I mean, all that information from the hardware through software. So if you walk into a building, what is always there is lighting. Whenever there's a building envelope, there's always going to be lighting. What else is always there is phones. I mean, every one of you probably, would not leave your home without your phone. Probably majority of you. I probably think, most of you would probably, if you left your home, drove somewhere or walked somewhere, probably drive right back or walk right back, even though you've gone, 10, 15 minutes away from home, because you need your phone. It's that important nowadays. I think the same importance could be said for lighting, right? You need anywhere where there's a building envelope where there's not direct sunlight, you need lighting. Or if you're operating or working in the evening hours, especially during these months, you're gonna need lighting, right? So it is right for us to take advantage of those technologies, both all the lighting and all that infrastructure, all that sensory network, and all the information that you carry with you with your phone, and be able to take those and combine those to make something more than just energy savings. And what does that lead to? That leads to people understanding, or business owners or owners understanding how some of those spaces might be used as far as where people are gathering, how people are traveling, how people find their way through a complex or unfamiliar place. And we do that using what Chase said earlier about Bluetooth technology, or is in our wireless luminaire now. Why not take advantage of that and be able to build upon that to direct people to where they need to go? Because everyone has a phone and there's lighting everywhere. So those things are already in place, right? You need to have those sensors and lighting in place anyway. The sensors are mandated by code, right? Lighting is required for us to perform our functions. And so it makes sense for us to take advantage of what is already there. And the energy savings that we get from a lot of these controls that we have in place definitely allows us to pay for some of those extra functionalities that we can now take advantage of and create a smarter building for us to leverage and really optimize our space, optimize our comfort level, and really be able to do something that we've been wanting to do for a really long time. So I think we're right at 12:31. I went over by about a minute. That concludes our presentation. Here's our contact information, Chase and I. There are more questions. We can answer that through email. Thank you very much for your attendance.
Thank you very much, Bo, and thank you all for attending. We had a fantastic question session in the chat box, so do photograph or do screenshot Bo and Chase's details for any lighting or unified lighting projects that you might have in this region, and even if it's outside, they can connect you with the right Acuity resource. Acuity is the largest lighting controls company in North America, so you should be covered no matter where you are. And once again, thank you very much. And next week, we are going to have our Tritium Niagara sessions. So it's going to be about the integration and the Niagara platform. And that will conclude our workshop. So with that said, thank you, everybody. And thank you, Bo and Chase.
Thank you, guys. Appreciate your time.
Thank you.